In this video, we will be doing two proofs involving the no choice theorem. So there will be one in yellow, one in red, and we've got the green note down here, which we will get to. So first, the yellow proof, we have the givens and the proof that are in here. We'll do the proof and put it on the diagram. So first, triangle ABD is isosceles with base AD, given. Triangle BCD is isosceles with base BD, given. Next, angle A is congruent to angle DBC, given. So angle A in this triangle is congruent to angle DBC over here in this triangle. So next, angle ADB is congruent to angle BDC is congruent to angle A because base angles of isosceles triangles are congruent. So notice angle A and angle BDA are congruent because this is an isosceles triangle. Angle DBC and angle BDC are congruent over here because this is an isosceles triangle. Then, because these two angles are congruent to each other, all four angles are congruent. From there, angle ABC is congruent to angle BCD, no choice theorem. If the sum of the measures of these two angles is equal to the sum of the measures of these two angles, then the measure of this angle must be equal to the measure of that angle. And that is our proof here. One thing to note for later when we get to this green note, note that triangle ABD is in no way congruent to triangle BCD. Next, we will go to the red proof. So we have our givens and our proof down here. And again, we'll do it on the diagram. So first, angle Z is congruent to angle XYW, given. Angle Z is congruent to angle XYW over there. And then angle ZYW is congruent to angle X, given. Angle ZYW right there is congruent to angle X up here. Next, angle YWX is congruent to angle YWZ by the no choice theorem. Angle YWX right there is congruent to angle YWZ over here, because if these two angles with the single mark are congruent and these two angles with the double marks are congruent, then this third angle here with the circle and this third angle here with the circle must also be congruent. It is also called the third angle theorem. If this first pair of angles with a single mark are congruent and the second pair of angles with the double marks are congruent, then these two third angles with the circles must be congruent. And again, notice that triangle YWZ is not congruent to triangle XYW. And that brings us to our green note here. You might be tempted to use AAS. Why is this clearly not possible, and what is the reason? It is clearly not possible because triangle ABD is clearly not congruent to triangle BCD. And down here in the red, triangle YWZ is clearly not congruent to triangle XWY right there. Next, what is the reason? So the reason you might be tempted to use AAS is because we have all congruent angles up here and we have all congruent angles down here, and we have what appears to be a reflexive side there and down here right there. It appears that we do, but we do not. And here is the reason. Looking down here, you can see YW in the big triangle is between the angle with the single mark and the angle with the circle. And in the small triangle here, YW is between the angle with the double mark and the angle with the circle. And again, up here in yellow, BD appears to be reflexive, but in the small triangle, it is between an angle with a single mark and an angle with a double mark. Whereas in the big triangle, it is between an angle with a single mark and another angle with a single mark. So in the small triangle, BD is a leg, and in the big triangle, BD is a base. So those are not corresponding parts of triangles. And that is why you cannot use AAS on these. AAS proves congruent triangles. In the yellow here and in the red here, the small triangle and the big triangle, small triangle and big triangle are simply similar triangles. They are not congruent triangles. And that is the reason. And that is our proof.